Hello guys and welcome back to the channel. Today we are going to do the third module of the course Inspect Rich Documents with Gemini Multimodality and Multimodal RAG. So today we are going to do Multimodal Retrieval-Augmented Generation, which is RAG, using Gemini API and Vertex AI. This is going to be an interesting lab. So let's just start the lab. It's 1 hour lab. We have to use credit points for that. Um, I don't know what was the issue, but I hope my credit points didn't go. There's 74, right? Alright, we are good to go. I was scared for a few seconds. Alright, let's go to task number 1 and just first open the console in incognito window, which you must be used to right now. Just click on I understand. Now you'll see an interface like this. Just select I agree and continue. And now just go to Workbench and open the Vertex AI Jupyter lab. Vertex AI Workbench. And then you'll see the instance name, which is Vertex AI Jupyter lab. Just click on open Jupyter lab. You will open it in a new tab. Then the second task is to open intro multimodal RAG. Okay. So we are going to, again, it is kind of what would I say? Like, it is kind of a notebook thing only, but over here you can see there are 7 tasks total, not like previous models. So this is a big, actually a big lab. So intro to multimodal RAG, just open this. You can close the launcher and just select Python 3. Wait for the kernel to connect. And it will take few seconds only. The kernel will connect and then just start with getting started. Install GenAI SDK for Python and other dependencies. Just what we are doing is we are installing Google GenAI and PyMoPDF. This is something new. Now we are going to just restart the kernel. Okay. I can just wait for kernel. Alright, now it's ideal. So we'll define a project code. Sorry, Google Cloud project info. So copy your project ID, paste it over here, copy your region, paste it over here, and just shift enter to run this. Alright, now we'll import libraries. Okay, so if you remember in previous lab I mentioned that you can display with markdown. So I didn't know what main libraries were, but over here, if you see python.display, import python and display, and this was the library needed. So just run it. Now load the, okay, we'll have to wait because it's getting executed. You can see the asterisk over here, the star sign. That means it's getting executed. The moment the number appears, it means it got executed. Now load the Gemini model. Just check it that we have asked to run Gemini 2.0 Flash. So we just have to confirm it and run the model. Now download custom Python utils and required files. So what we are doing is basically we are downloading it from this is a command prompt command which we are using in Jupyter Labs, so that is why we have used exclamation, and we are downloading the GitHub repo. So in that GitHub repo we got few things which we just completed, downloaded. So now building metadata documents for containing text and images. Okay, let's just see what we have done till now. Just task 1 is done, task 2 is done, and now in this task run through notebooks as in load model and download helper functions to get the documents and images from cloud. So we haven't run the helper functions, right? Okay, so first we are going to import helper functions to build metadata. Before building the multimodal RAG system, it's important to have metadata of all the text and images in the document for reference and citation purpose. The metadata should contain essential elements including page number, file name, image counter, and so on. Hence, as the next step, you will generate embeddings from the metadata, which will is required to perform similarity search when querying the data. So we'll just run this, and now we have to extract metadata of text and images from the document. So what just we imported? We imported get document metadata. This function extracts text and image metadata from a document and returns two data frames, namely text metadata and image metadata. So you're going to get you're going to get two data frames in the output, which will be one is text metadata and other one will be image metadata. So let's just start this. Do not send more than 50 pages in logic below. It is not designed to do that, and you will get into quota issue. Okay, so what we are doing over here, before that I am not sure we have completed this or not. Okay, we have completed that. Build metadata of document containing text and image. Okay, so we are over here, right? Because we'll have to constantly check the manual, because here are few steps given which you have to follow. So we'll just have to read it properly and then we have to go ahead, otherwise we might get an error at some point. Source data that you use in this lab is modified version of Google 10K, which provides a comprehensive overview of company's financial performance. Okay. What we are just passing is so this is the actual path of the if running on Google Colab. Okay, so if you are running on Google Colab, you have to uncomment this, like remove this comment if you're doing this on Google Colab, and if not, then it's fine. Then we are specifying the image description prompt. You can change it if you want. Explain what is going on in the image. If it's a table, extract all extraction of the table. If it's a graph, explain the findings in the graph. Do not include any number that is not mentioned in the page in the image. We are passing Gemini 2.0 model. PDF folder path is over here. Then image save directories, images, and image description prompt is also given. Embedding size is also given. Uncomment this if you are running into API quota issue. So let's just see. First, we'll just run this. If we encounter into an issue of, mm, let's see, if we run into API quota issue, something like that, then we'll just run the remaining command. We'll uncomment them and run it. Till then, I'll just read this. And as the original document is rather large, we'll be using modified version with only 14 pages split into two parts. Instead, although it's truncated, the sample document still contains text along with the image such that table starts in graph. To extract store metadata, we are doing that only. Okay, completed processing. Now you completed the processing. Parameters for Gemini API to call. Hmm. Okay. Let's start the search with a simple question and see if the simple text search using text embedding can answer it. The expected answer is to show the value of basic and diluted net income per share of Google for different shares, for different share types. Before that, let's see where exactly are we, because mm, okay, because we are getting something like parameters for Gemini API call. Okay, so these are basic parameters which we use for Gemini API call. So they are just given it. If you need it, then inspect the process text metadata. So when we give the, we have saved it in a text metadata df. So when we use the dot head function, we will get top five top five columns of everything, the top five data from the data frame. So this is the top five rows and column, top five rows basically, and all the columns will be there. Now what we are going to do is do the same for image data, which we also did over here. We got that also. Now we are going to import some helper functions, which is get similar text from query, print text to text citations, get similar image from query, and etc. We have imported all this from intro multimodal RAG utils. Okay, these are helper functions of RAG. Now we are going to do the text search which was asked for the task 5. So your query is, I need detail for basic and diluted net income per share of class A, class B and class C share for Google. We have stored it in a query variable. Now search similar text with text query. Over here, matching user text query with chunking embedding to find relevant chunks. So what we are doing over here is, first we'll use the get similar text from query method, which is just passed it over here. In that, parameters will be query, which is just about us, then text data and text metadata frame, metadata data frame. Then we are going for column name. We are going for specifically for text embedding chunks. So it is over here. This is the last column which we are using to find the relevance. Now top n is 3 and chunk text is true. Now match the, so print the match text citations. Print text to text citation, matching result, text is the name, print top false, chunk text true. Let's just run it. Citation 1 match text. So this is some score. This is the file name, page number, chunk number, and the chunk text. So what we are doing over here is basically we just uh, how would I say, like uh, in the PDF folder right now we just created a data in which we have two part 1 and part 2 samples, which was just mentioned over here, like over here. Okay, so we are using that data, and this is from part 2 sample, and here are some text sources. This is embedding text. Embedding means basically vector. It is basically numbers in a vector format. Vector format means in of one dimension. So this is entirely one list of, or we can say just one array of numbers. So it converts text to numbers. This is chunk number is 1. So over here also chunk number is 1. So over here there are two chunks. So there will be two arrays of embedding probably. And then what is the chunk text? We are seeing that entire chunk text, and the embedding of the text embedding chunk means this was the uh, text embedding for whole page, and this is for the just for the chunk. So that is where that specific part, chunk means a specific range of uh, part we can say. Or just the specific range of PDF. So this is the chunk which we got related to the related to this query. So that is where its score is 0.76 means 76% match. Then the second is 0.7 means 70% match, which was on page number 3. There was one chunk which was related. Then citation 3 is 67%. Again on page number 3, chunk number 2. So this was the entire chunk. So what we I hope you got to understand what we just did. We, with the help of this, get similar text from query. What we did was these numbers were so basically these words were converted into numbers. So it converts the query into number and understands the similar score, creates a similar score, and that similar based on that similar score it is giving the entire chunk because we asked it to, because the chunk text was true, so it is giving the entire chunk of the data. And because we have top n is 3, so we are getting the top 3 results. You can see the first high score match does have what we are looking for, but upon closer inspection it mentions that the information is available in the following table. The table data is available as an image rather than as text, and hence the chances are you will miss the information unless you can find a way to process images and their data. However, let's feed the relevant text chunk across the data into Gemini model and see if it can get your desired answer by considering all chunks across the document. This is like basic text based RAG implementation. So in the uh, first chunk, which is more relatable to the query, we got to know that the following table set for the computation of basics. So basically it is mentioning that there is a table over here which will be explaining or which is more related to what we asked for, but we didn't got the table because it was image. So over here what we are doing is printing all relevant text and found across documents based on our user query. So we are just trying to get the items. Let's see. Let's just read it. That we are joining value chunks, key value and matching results dot text items. Alright, now instruction is answer the question with the given context. If the information is not available in the context, just return not available in the context. Question is query, which was passed earlier. Context is now what we just gave, and answer you have to give it. Okay. What we are doing in context is key value pair we are making of the matching result text, which was just now this basically. All this is a key stored it in a key value pair, right? Score is the key and value is 0176. So we are doing it in that format, and value will be chunk text. So we are just passing the chunk text, not the entire response. Okay. I'll prepare a model input. It is instructions. I don't know if we already gave the instructions or not, but I can find if we ever pass the instructions over here. So let's see. We'll just run through it. Before that, I guess we'll have to check this if it is mentioned over here somewhere. Okay, we have to run section text search and wait for a few minutes. Acha, okay, we haven't run the entire text search section, so let's just run this. Let's see what results we get. So the context status that the net income is this. It also mentioned that table will be with the computation of basic that are available, but these tables are not included. Therefore, I cannot provide the specific details you required. So you can see that it returns that provide context does not include the details for basic diluted net per share. So this is expected as discussed previously. No other text chunk total 3 had information you sought. So in previous, like in these 3 text chunks, only one was related, other 2 was not that related, that much related. And in the the first one which is more related, it has data, but it has a table in it which is considered as image. Also, similar images with text query before that. Okay. So since plain text didn't provide desired answers and the information may be visually represented in a table or another image format, you will use multimodal capability of Gemini. So the goal here is to find an image similar to the text query. You may also print the citation to verify. So we are giving this as a query. Again, now we have the column name is text embedding from image description, which is text embedding from, okay. We are passing the another image metadata data frame is being passed. I didn't saw that. So we are passing text data frame as well as image data frame, but only for this. And image embedding is false. Text embedding instead of image embedding. Use text embedding. Okay, if you want to use text embedding, top n is 3. If you want, you can just print this. Otherwise, it's fine. Okay, we got the. So what happened is now we got the table. We got the image of the table, entire table. So what did we do exactly? Instead of searching for the text embedding columns, we searched for the image description column, which was an image data frame, and we just again the same thing was that we gave some embedding size to it, and basically the most related to the query was uh, all output was given and based on images. So in images we got just one output because in other two there were no images involved. So that is why we got just a one output. And also no, so there might be three involved, but when we were displaying we asked for the first one only, so that is why we got one output. Okay, so it found exactly what you were looking for. You wanted details on Google plus A, B and C. Now you can also send the message send the image and description to Gemini and get answer in JSON. So what we are doing over here is just passing the image results, and as image object description is passed. Instructions we are giving as answer the question in JSON format with the given context of image and its description. Only include values like this. And again we are doing the mm, it is in markdown format now. Let's just run it. Okay, we got the response that class A basic net input per share is this, for B it's this, for C it's this, for A diluted net is this, for B it's all same for them. Okay, so you can check the citation to probe further. Check the image description, which is or description extracted to Gemini, which helps search a query. So over here what we're looking at is matching results image. We printed that and just top one is true. So over here the image description is also given, which was done by Gemini. Now that we have completed our task 5 and we have 30 minutes left, just there are two more tasks, image search and there will be multimodal retrieval-augmented generation. So first we'll just do the image search similar image with image query. Over here we have a tic-tac-toe sorry, a tag table revenue.png, printing the message and loading the image. This is the image. Now search for similar image based on input. So based on input image and image embedding. So this is the input image which we are given, and based on image embedding which we did previously, like just now, we will search for similar image. It did find similar looking table which gives more details. So if you see, I think it is same, but we got the same table, I think, because there is nothing different over here. So let's just run this. Now here what we are going to we are displaying the entire citation. The first citation which we got for the image, like text to image citation, we are just comparing it, like displaying what we got, and the score was 99%, like we got the same image. Okay, now check other matched images optional. You can access other two matched images using this code. So just run it, and so if you see that there basically these are two different images, but coincidentally the details are same. That is where we got confused over here. But this is a different image itself, because when we asked for different image, I also said that this is the same image, it looks like it. That is why when we looked in detail, we got the score as 99% same. It might have a different page number or something else might be different in it. uh, in the detailed part, you have to read this description. And when we saw the other two images, these are the other two images. Among them, one is again same to same, and this is the other image. Alright, now what we are going to do, we are doing comparative reasoning. Let's apply what we have done so far to doing comparative reasoning. For example, you search all images for specific query, send those images to Gemini to ask multiple questions where it has to compare and provide you with answers. So queries show me all the graphs that shows Google Class A cumulative 5 years total return, and the column is mentioned over here. Let's see, we are just running this function in this variable. We just stored it, and now check matched images. So we are just checking the top two images over here, and these are all, and both are different images, but like we mentioned, graph shows Google Class A cumulative 5 year total return. So it shows all alphabet inclusion class A for both the records. Over here it was low and then suddenly spiked up. Over here it was equal, and all of them spiked up equally, but it was just more. Now we are giving another big prompt. Over here we are giving instructions that compare images with Gemini and extract text provided as context to answer the question. Make sure to think thoroughly before answering the question and put a necessary step to arrive at the answer in bullet points for easy explanation. These are the context given, these are the questions asked, and we are using rich markdown for the better markdown process. Get Gemini response function is used. Multimodal, we are passing that Gemini 2.0 prompt. I just told you this was the entire prompt itself. Stream is true, so if you run this and look at it properly, though, you will see the answers generating itself. And generate config, we are given temperature 1 means less creative, stay more to the fact. So it has compared mostly whichever questions we have asked, it has answered those questions. Okay, now multimodal retrieval augmented generation, this is RAG. Okay, so let's bring everything together to implement multimodal RAG. Okay, first we are doing user query. So this is the user query. We passed it. This is the task 7, by the way. Now we'll get all relevant text chunks. So get similar text from query is the function which we will use, because we will get all the similar text. It explains itself actually. We just give the column name because we are using text data, so from text embeddings. Now we'll get all relevant images from image metadata. So text embedding from image description was used, and we are taking top 10. Okay, last time we were taking 3, but now we are taking top 10. Now create context text and context images. So we are creating all the context text and context images, like all the relevant data and their descriptions will be. So let's see, context text is for key values and matching results chunks, which is this, which is just created. So it will append chunk text into the array which we just created, an empty array. Again, same will be happening in the context image. So we are just right now we are assigning the roles to everyone, so that is why no output is here. Now pass context to Gemini. So we are passing instructions. This is the context we have given. Over here, if you see, the final context is given, and here there is this context. So what final context is? So after appending all these, we have given /n and then join the context text. So /n means basically enter. It is used for gap of enter key. When you press the enter key, you come one line below, right? So that is what /n is. So that's what we did, and that was text context, image context, and query also passed. And now we have to just generate the answer, like get the answer from the Gemini. We have also passed all the other necessary parameters, and again, we are not asking it to display it right now. We have just stored everything. Okay, we have asked, okay. I thought we are storing this somewhere. Okay, we have asked it to deploy. Sorry, we asked it to display. So over here it has displayed the reasoning and every questions which were asked in this instructions. Now print citation and references. So to print that, we are going to display the images of each description. So and we have resize ratio of 0.5, means 50%. We are just creating everyone in the same size so that we can see it in a clean way. Otherwise some images might be bigger, some might be smaller. So that was it. Image citation, you can check how Gemini generated metadata helped in grounding the answers. So this was the exactly these are the metadatas which we uh, which we got as an help. And again for text also, we asked for 10 citations, right? So these are the 10 citations which basically help to create this exactly the 10 related images, like these are the references and answering all these questions as well. So we have completed our lab. 6th and 7th module is also okay. 6th module is done. So there are two check my progress sections in 6th module. So we have done this lab as well. So congratulations, guys. Now the thing is remaining is the challenge lab. Hope to see you soon in that lab as well. Also to check here also. It might take few seconds to show it on your profile. Okay. Thank you guys. Hope you like this video. Just close the incognito tab, end the lab. Okay guys, thank you so much for watching these videos and supporting me. Hope you like this video. Do like, share and subscribe to my channel, and see you guys in the next one. Thank you.